Okay, in this example, what we're going to do is we're going to measure the smoke density of the smoke from the oil-fired unit in the breech in the flue pipe. And here you can see the smoke vapor with the scale. The scale goes from 0 to 9, 9 being the darkest. What we want to do is we want to get our smoke level. We want to smoke below 0, around 0, below the 1 mark. I'm going to show you how to do it. Remember, when we're done setting this thing up, we can't have any smoke. So again, when we're done, we're going to be in the 0, at a 0. I want to find a point where we just have a trace, though, to start with, and then you do your CO2. In this case, I'm just going to show you how to do the actual smoke test, and then later on we'll talk about the knee curve in one of the other videos. So again, we're going to use this to tell how bad the smoke is, and we have to get all the smoke out. 1/8 of an inch of soot is equal to an inch of fiberglass insulation, which is about a 25% increase in fuel costs. So we can't have any smoke. Plus, we don't want to put our combustion analyzer in a system that has smoke because it's hard on the sensors. I'm going to go through sensors. So I'm going to do my smoke. This is my smoke pump right here. Real simple device. They're not that cheap though, around $100 some. Before you even put it in, we're going to get our paper out, and we're going to put our paper in our smoke pump device. Now what I'm going to do first is I'm going to put my paper in, unscrew this, slide the paper in, and then I'm going to screw it shut. Screw that shut. I'm going to hold my finger on the end of the pump and make sure that I can't pull the pump. Because if I can pull the pump, then that means my gaskets are worn and I got a leak somewhere. So then I'm going to pull the pump a couple times. And what I'm doing is just making sure my tool's working. By pulling the pump, then I'm going to open and I'm going to look to make sure that that's 0. Because what can happen sometimes when people use these, they put them in too far and they scrape carbon inside the tube, and then you'll get smoke when you don't have any smoke. So it's always good to start off with that to make sure that the device is working good, your pump's working good. So now I'm going to put my paper back in, simple white paper, insert it into the breech after my furnace has been running for a little while, 5 minutes or so. And I'm going to do 10 pumps. And that's about roughly 2,200 cubic inches of smoke there that we put in. Now we're going to look for 0. So now I pull it out and look at my smoke, and you can see we have 0 smoke there. So I really would, what I'd want to do in this case is 0 smoke. I want to close my air dampers down on the oil unit to try to create a little bit of smoke so that we know where the trace is. And here you can see the air, my air dampers. This is my fine air adjustment, my fine air shutter. That's my coarse air band. So I want to close them down a little bit just so I can find out where I begin to have a little bit of smoke. That way I know where the 1 and 0 is. Then I want to find just to the point where it gets to 0, take a CO2 reading, and then come down 1%. And we'll talk about that later on. So in order to get rid of the smoke, we're going to use these dampers here and allow more air in. That's how we control how much smoke density. This is our excess air. Remember, more excess air means less contact time, which is bad, and a higher stack temperature, which is bad, and lower combustion temperature, which is bad. So the only reason why we really want to add more excess air is to get the smoke density to 0. You cannot have smoke. And that concludes this portion.